The James Webb Telescope has taken a new image of the most distant star ever seen. The star is nearly 28 billion light-years away from Earth. At such enormous distances, we can usually only see galaxies, but a lucky coincidence has allowed researchers to spot this star with the Hubble telescope and then observe it again with the James Webb Telescope. The star is called Earendel, which means the morning star or the rising light. This star resides in a galaxy called the sunrise arc. The light from the star has been stretched into a long curve by the gravity of a galaxy cluster closer to Earth in a process called gravitational lensing. This process also magnified the galaxy, allowing astronomers to confirm that Earendel is an individual star and not a cluster of hundreds of stars. The James Webb Telescope was designed to see the first galaxies that sprung up in the young universe in the first millions of years after the Big Bang. Astronomers thought that it would be impossible to see individual stars that formed at that time. But gravitational lensing might actually enable them to see inside those early stellar groupings in detail. We can see Earendel because it is perfectly aligned with the galaxy cluster to provide the maximum possible magnification. We are extremely lucky, as nobody has ever seen a star this highly magnified, not to mention a galaxy. Earendel is more than 10 billion light-years more distant than the next furthest star astronomers have ever seen. Because light takes time to travel, we are now observing Earendel, as it was about 900 million years after the Big Bang. Stars in the early universe are expected to have different chemical compositions when compared to modern stars. This is because heavier elements were formed over time in supernovas. Not enough supernovas had occurred back then to enrich space with the elements that are so common now. The next round of James Webb Telescope observations, planned for December, should help unveil what Earendel and the Sunrise Arc galaxy is made of. We're all made of star stuff, but that stuff wasn't around in the early universe. This is a rare opportunity to see if the heavy elements were there in this star 13 billion years ago.